Hi, my name's Alex. I lead product management for Q-CTRL. Some of you may be familiar with the company. Um, to be clear, I don't lead any of the research efforts necessarily. I focus more on the usability, scalability, and all the interfaces for our products. I make sure that all of our users and customers can reliably access all the capabilities that we're building. So true to product, I'll provide a quick roadmap of our session today. So I'll cover a little bit, I'll just recap a little bit about what we do, what the core problem is that we're addressing. I'll focus on a lot of our product portfolio, just to give you all a sense of our ambition to really make quantum technology useful and how we address specifically performance management. I'll dive into a recent launch and integration we have with IBM specifically, and then end with a few use cases as well as where we plan to go next. So before I start, how many of you, with a show of hands, how many of you would describe yourself as more experimentalists or academics? Some, or how many of you would then describe yourselves as perhaps part of enterprise teams, researcher, or it could be R&D teams, but more on the enterprise and commercial side. Okay, so it looks like more on that side, so that's great. So you may all know this, but at Q-CTRL, our goal is to build and commercialize AI-powered infrastructure software with the mission, in service of the mission to make quantum technology useful. So we have software that sits right at the firmware layer above the hardware. However, we provide entry points and applications all the way up to the developer and algorithm level. So we allow our customers and users to access different points along the stack. But what we try to do is embed ourselves as close to the hardware as possible in order to boost the resiliency and overall performance of the hardware. So you may have seen this. This is, again, Grover search, typical needle in haystack unstructured search routine. And this is why I imagine all of us are here, both on the research and on the enterprise and commercial side. We're trying collectively to address these errors. But from a product perspective and from usability perspective, I care about this a lot because, first and foremost, these errors lead to failure in the application. So it just defeats the purpose of why a user would want to even access a quantum computer. These failed experiments add friction and frustration. If you go to any of these conferences, I came from another conference earlier this week, and we would often hear about frustrations that users had because of the lack of any kind of error reduction tools that they had available out of the box or accessible to them. And then dealing with this error, again, is often out of reach for a lot of enterprise users, even for academics. They spend all their time trying to come up with techniques just to reduce these errors, suppress the noise, but it's still limited to a small cohort of experts. And so what we do is we deliver a fully automated error suppression pipeline that we have built in-house proprietary, but have deployed commercially in accessible through a Python, a fully scalable, easy to use Python client that's executed with a single line of code. And we have plenty of documentation that actually provides this out of the box. So we have templates where you could actually use this, switch and swap the specific circuits and algorithms you want to use, and it's ready to go. One of our product core values is really to make the complex simple. So underneath the hood is a complex proprietary workflow that we have built from a lot of pre-processing compilation, dynamic decoupling, and we do this all preventatively to reduce the amount of runtime and resources that a user needs to consume in order to execute a single job. And so this is how we're trying to make the complex as simple as possible. All of this is underneath the hood and abstracted away from the user. So all the user needs to care about is executing a single line of code and getting the right result. And so that's the bottom chart there is what we ultimately aim to do. We want to build products, hardware validated products, and we're agnostic to different types of hardware architecture and quantum modalities. We've worked on dozens of architectures already and have validated our pipeline, our techniques across all the different providers. So at the end of the day, we want algorithmists, enterprise customers, as well as academics and researchers to be able to get the right result and get accuracy out of it. So our ambition, like I mentioned before, our ambition to make quantum technology useful extends beyond just error suppression software. So this covers a lot of our other product portfolio, everything from education and workforce development. So we have an edtech tool called Black Opal, which is a very interactive visual tool that anyone can sign up for and experience out of the box for free. We have a free tier to learn about quantum computing. So we have a lot of enterprises where teams are deploying this as training to equip their teams and prepare to invest in quantum in-house in their own companies. We also have universities that are deploying this as part of their accredited coursework. And then on the far, in the middle here is really kind of speaks to a lot of our the pipeline, the workflow that I just described. We deliver it, and I'll go into this in a bit more detail, but we deliver it in a few different ways. One, through a standalone client called FireOpal that any user can just download and experience. We also have another mechanism in which we deliver it called Q-CTRL embedded, where we interface and integrate directly with the hardware vendors themselves. So we integrate directly into their stack. And I'll describe that in a bit as well. We also have a product called Boulder Opal, which is more around hardware characterization, automation of experiments and optimization. So this is primarily for the experimentalists and the academics working on early stage and experimental hardware, trying to understand the characteristics. I provide this URL because you could simply access and as well as download or sign up for an account for any of these products. So with Black Opal, like I mentioned, we're really excited about this, not only because of what has been built, but really what value it's actually delivered. So I just checked as of earlier this week, but only a couple months ago, we were at about 10,000 users. Now we're well past 12,000 users. What I'm also really excited about is how we've had at over 5,000 certifications, meaning that people have completed and have verified the knowledge and the expertise that they've developed through taking this course. And there's been a number of accounts of stories I've heard of how users who were not in the quantum industry, but by completing this course have gotten jobs at a lot of quantum companies. So that, to me, is the most powerful anecdote that I would love to hear, is how people have actually been able to make meaningful change in their lives as a result of products like this. Going forward in the next year, we plan to do a lot more, especially around the workforce development space, to train up companies, to work with consultancies, as you can see here, to deploy this with other industries and other verticals who are catching on to quantum and want to invest in a future technology within their company. And again, here you can sign up, you can explore if you haven't already, and anyone can, it's completely self-serve. So you can sign up, try it out yourself. And if you want to deploy this in your company, you're welcome to talk to me or contact us. Boulder Opal, again, is a package that works with experimental hardware. We work a lot with early stage quantum companies that have commercial ambition, who are trying to scale the kind of a new type of quantum architecture and hardware that they're working on. We also work with a lot of universities too. We recently had a webinar with Nord Quantique, where they are working on some cutting edge error correction approaches, quantum error correction approaches, using as a result of their extensive use of Boulder Opal. One other part here is that we've been, especially if you're an early stage quantum hardware company, that are really trying to tune up, autonomously tune up 1 qubit, 2 qubit gates with their hardware. We have demonstrated capabilities of doing this in less than about an hour. Sometimes an hour and a half, we can demonstrate this. We've done this already on superconducting architectures, and we're exploring other architectures and modalities as well. So we can work with your teams if you're in that stage of really trying to bring up your devices. Yeah, and then FireOpal is the standalone client that has demonstrated the 1000x algorithmic performance gains. The other part here that we also want to highlight is because of our preventative error suppression approach, we do this at a lower compute cost, lower resource cost compared to maybe some default settings you may use. So because it's preventative, it reduces the amount of shots and executions you need to make, as well as the amount of runtime. So for those who especially are trying to explore how to incorporate this into your workflows and have recurring use, this becomes a growing concern, especially related to your budgets. And if you're an experimentalist working on new types of algorithms where you don't even know how many executions you need to make, this is even more of a concern because you need to manage your contractual budgets and not deplete your spend in your budget immediately. And again, we do this all within one line of execution. We are fully supported on all different IBM devices today. And we are launching our integration with Amazon Bracket very soon. And we'll be rolling out additional support through the backends that they support. And the other representation of this is Q-Control embedded. So one of our other product principles here is to live where users live. And so what we've done here, which I'm really excited, and I'll kind of walk through just a quick step-by-step flow of this, is we have natively integrated our error suppression pipeline on IBM Cloud and within IBM's quantum platform. And so it's natively integrated, same thing, simple configuration. So I'll show you that it's just one line of code, the one line setting that you have to set up in your Qiskit scripts. No additional cost. So this is part of the existing standard plan. For those of you who have used IBM Cloud, who have used set up Qiskit instances, it's part of their $1.60 per second runtime cost. So not an additional cost, and it's available today. So this is not something that's coming soon. It launched last week, and it's completely available to use for anyone who is curious about trying it out. And again, this is how we want to make sure and bring these capabilities to the thousands of users of IBM Cloud. We want to bring this, we want to live where users live. We want to make it easier for them to access this technology. And the world was noticing, there's a lot of news reports, and you may have noticed some of the signage that was also in Times Square that was deployed at the time of IBM Summit. And so getting started and using this integration that we just launched is very simple. You can get started in 3 easy steps. And I'll walk through these steps really quickly. So the first is, again, if you're familiar with the interface of IBM Cloud, you select the standard plan. Right after that, you have to select the performance management strategy you want to use. So right there, when you select, there is a Q-Control automated error suppression option that you have the option of choosing. Once you do that, you simply you create an instance and just copy your CRN. So this is a one-time thing that you have to do. Once you have that, you set it and forget it. The last step is to enable the channel strategy. So if you followed any of the Qiskit runtime notebooks, you are well familiar with setting your service, and you likely will have already set your channel. The only additional thing you have to do is select your channel strategy, set it equal to Q-Control. After that, that's all you have to do, and then you can start to deploy whatever custom scripts that you have. And the other part of this is that what we really care about is making sure that we are consistently delivering performance. And so especially as part of this integration, we have a page in our documentation where we show our benchmarks. So we benchmark daily today across our products. And we know that there's no single benchmark that tells the complete story. So if you go to our docs page right there, we benchmark, and this is just an example of Bernstein-Vazirani, a common algorithm, especially as part of the US QED benchmark set. We benchmark against success probability, selectivity, and confidence level as well. So yeah, one of the things you'll notice is that with increasing circuit width, which is something we are constantly pushing the boundaries of, one single shot for success probability will goes down over time. So we try to provide a more holistic story around that with selectivity, showing the signal to ratio, the probability that you'll still get the right answer over wrong occurrences, and then the confidence level in terms of how many shots over time and how many what confidence you have depending on the number of qubits you're running. We do this daily, and we have plans to make this a bit more real time as well. In the same way that a lot of companies have a status page for the uptime and downtimes of their services, we are exploring doing something very similar. So we provide at least a daily monitor of benchmarks against several different algorithms. We, and again, this is part of our company core values of being true, being revered. We want to make sure that the performance we're delivering, not only will end users get the value out of this, but for you to, even before you run an execution, you can go and look at our latest benchmarks, see how it's performing against other options, and especially without Q-Control turned on. And then, and the other day, and I think earlier today, there were other talks by our partners such as Blue Qubit and Capgemini that have also shown some of the demonstrations and benchmarks for their algorithms, both with and without Q-Control. So if you haven't seen it, I encourage you to also look at the recording of their presentations. One case study I wanted to also feature was something that we recently ran with a big Four firm. They were interested in DNA sequence alignment. They had published a paper around a new approach to DNA sequencing, and they had tested with IBM simulators. And so they wanted to try out our product, our integration with IBM, before we actually launched. And so we did this on IBM Algiers, one of their last remaining 27 qubit device that's online right now. And the results that we showed were that with our option in our integration with IBM, there are 3 tests that we ran for the simplest algorithm. Both with and without got the right answer. However, or had the right alignment. However, we actually had twice the strength and signal to indicate what the right answer was, to provide that additional confidence. The other 2 more complex tests, only with Q-Control turned on was the right answer outputted. So we had demonstrated, and the firm was really excited. They actually presented these results at the IBM Summit earlier this week as well. Yeah, and this is just validation from some additional, both obviously IBM as a partner, and their excitement from Jay, as well as Capgemini as a trusted longtime partner as well. And we already have plans to continue to deploy this for future work. I'll end off with this, which really, again, just I want to kind of give a tease in terms of just additional work that we plan to do. Our goal is to be flexible, integratable, and interoperable with both software packages, different programming frameworks, as well as to be hardware agnostic, to be able to connect with different hardware vendors if it requires natively integrating or integrating through cloud accessible interfaces. Either way, our architecture and our technical specs are flexible for any kind of interface and any kind of architecture. And so our goal is to live where users are. We want to make it as easy as possible for any user, regardless of what your operating environments are, your programming frameworks, as well as what workflows and tools you have set up. We want to be able to be as seamless as possible with your workflows and to make your lives as easy as possible. So yeah, so if you want to learn more, I'll be here. If you want to connect with me, you can always learn more about our company and our products by getting in touch. So thank you.